Hello students, you're welcome to class once again. It's another time for us to learn mathematics. And in this video, we will be looking at a continuation of our last week topic. So we will still be talking about graph. But this time, we will be extending it to an in-depth knowledge where we will be looking at issues relating with plotting graphs. Okay, so we'll be looking at straight line graphs. Now it is also important to know that straight line graphs are also called linear graphs. Okay, so let's go there. Now a graph is a drawing showing the relationship between two or more variables, usually at right angles. Okay, so this is of course what the graph sheet looks like, and this is what we'll be using to work. Now in plotting a graph, the first step is choosing a scale. Now why do we choose a scale? And first of all, you may ask, what is a scale? Now to scale means to represent actual figures in smaller units. Let's say, for example, you want to draw your house on your piece of paper. Your house is bigger than the paper, but you can still do that considering some things. And one of those things you consider, one of those points you consider in plotting a graph is to consider the table of values, which you are going to see later on. And the second point in plotting a graph is that you should choose a big scale to cover at least 2/3 of your graph sheet. By 2/3 I mean 2/3 of the graph sheet. So having done that, let's say a rectangular piece of land measuring 600 meters by 400 meters. Now you are expected to represent this rectangular piece of land on your graph sheet. So how do you do that? Now let's say we are using a scale of 1 centimeter to 100 meters. So what this means is that on your scale, on your graph, every line you draw of 1 centimeter will represent 100 meters. It represents 100 meters of actual land space. So if 1 centimeter represents 100 meters, then it means that XCM will represent 600 meters. Now we are trying to find how long of a line, or how long a line we would draw on the graph sheet or on our paper that will represent 600 meters. So of course, when you have something like this, your next step would be to cross multiply. So if you cross multiply correctly, you would have that XCM is equal to 600 meters times 1 centimeter all over 100 meters. And when you do your calculation correctly, you would have XCM to be 6 cm. So this means that 600 meters of actual land space can be represented as 6 cm on a graph. So that is how you do look at that aspect in choosing a scale. Now going forward, of course, in our major topic for today, we'll be looking at linear graphs, which means straight line graph. Now let's take an example. Let's say that Chukudi walks along a road at a speed of 120 meters per minute. Now our question is that we are expected to use suitable scales on the horizontal and vertical axis to draw a graph of this information if he walks for 5 minutes. Now, when we say that he walks at a speed of 120 meters per minute, it means that for every 1 minute, Chukwudi would cover a distance of 120 meters. And of course, you would expect that for 2 minutes, he would have probably covered a distance of 240 meters and the likes. Now for this, our first step would be for us to look at a possible table of values. And what do we mean by a table of values? We mean a table that contains information of what we will be plotting on the graph. Now here I am going to be teaching you how to make a table of value. So listen carefully. Now from the question, we are told that Chukwudi walks at a speed of 120 meters per minute. Now we have here a table having 2 rows and a number of columns. Now on the first row we have time in minutes, and on the second row we have distance in meters. Now of course at 0 minutes Chukwudi has not walked, so he has covered a distance of 0 meters. But for 1 minute we are told that he would walk a distance of 120 meters. So, and we are told to draw the graph of him walking for 5 minutes. So if for 1 minute he walks for 120 meters, at 2 minutes, what is the distance that you would expect him to have covered? At 30 minutes, what is the distance? At 4 minutes, what is the distance? Now, of course, if he walks for 120 meters in 1 minute, you would expect that for another 1 minute, which will make it 2 minutes, he would have covered another 120 meters, making it 240 meters. So basically, we will be having an addition of 120 to the respective size. And if you do that properly, you have your table of values to be in this way. At 2 minutes, he would have covered a distance of 240 meters. At 3 minutes, 360 meters. 4 minutes, 480 meters. And 5 minutes, 600 meters. So that is how you make your table of values. And the next step will be for you to choose a scale. Now listen properly. When you get much used to plotting graphs, you may not need special formulas to choose a scale. By mere looking at the table of values, you should be able to decipher what scale you are expected to use. But for this intro class, I'm going to be teaching you how to choose a scale using a formula. Now remember that earlier on we said that one of the steps or points to note in plotting a graph is that your graph must cover at least 2/3 of your graph sheet. So let's say we want to plot our graph on this square, this red square, and of course if you look at it properly, it is over 2/3 of the graph sheet, so you can use that space and it will be correct. Then what will be our scale? We can find our scale using this formula. That scale is equal to range of values over number of large boxes. Range of values over number of large boxes. Now let us first of all look at how we could get our number of large boxes. And look at this graph sheet here. This is the point we said we want to plot our graph. Look at this arrowhead. It is on a red line. So starting from this point, starting from that vertical red line where this arrow is, to the next vertical red line. That gives you one large box. From this point to the next line gives you another large box. That is two large boxes. From there, going up to the next one gives you another large box. That is three large boxes. From there also to the next one gives you four large boxes. And from there to the other line gives you five large boxes. So we have five complete large boxes in the space where we intend to plot our graph. So that is how you know the number of large boxes. Now to look at the range of values, you have to go back to your table of values. But first of all, the formula for range is the largest number minus the smallest number. So when you come to the table of values, let us start with the first row, which is for the time in minutes. Look at it carefully. What is the largest number there on the first row? I believe I heard you say 5, and that is correct. And the smallest number is 0. So using that, our range of value will be 5 minus 0, which is equal to 5. Now we can come back to our formula that says that scale is range of values over number of large boxes. So imputing what we have, our scale will be the range of values, which is 5 minus 0, which will give us 5, of course, divided by the number of large boxes, which from what we counted, we have 5 large boxes. So our scale is 5 minus 0 over 5, which gives us 5 over 5, and which ultimately gives us 1. Okay, now what this means, remember here our answer is 1. What this means is that one large box on the x-axis of the graph will represent 1 minute of the actual value on the table. This is because when we are plotting the graph, we are going to plot the time as we are going to be using the time as the x-axis and the distance as the y-axis. So we just calculated for the x-axis, and we say that one large box on the x-axis of the graph will represent 1 minute of the actual value from the table. So if you want to write this, remember that one large box of such on the graph, if you use your meter rule to check the length, it measures 2 centimeters. So if one large box will represent 1 unit, which is 1 minute, so we can also say that instead of writing one large box, we write 2 centimeters. So 2 centimeters will represent 1 minute. And how do we write that in mathematics as a scale? We say 2 centimeters to 1 minute, or we can say 2 centimeters to 1 unit, or we can simply put it as a ratio, 2:1. And this, like I said, is the scale only on the x-axis. Now we can go further to draw our line, our x-axis on the graph like this. And then of course our x-axis is for the time in minutes, so we also write that underneath it. And the second part for the y-axis is the distance in meters. So we can simply come here, this point where the x-axis and the y-axis meet, like we informed you in the previous video, it is called the origin, and it is designated as 0. So since our scale is 2 centimeters to 1 unit, that is 2 centimeters to 1 minute, It means that the first large box will write 1 to represent 1 minute. The second large box will write 2 to represent 2 minutes. Then the third large box 3, fourth large box 4 minutes, 5 large box, the fifth large box 5 minutes. So this is how you write your x-axis for this graph. And the next thing for us to do will be to look at the y-axis. Now the same thing, you are going to use a scale. I'm going to calculate the scale using the formula scale is equal to range of values over number of large boxes. Now if you look at the graph very well and also look at this table of values, remember that the scale is largest value and that the range is largest number minus the smallest number. Now we are looking at the distance, the row for the distance. The largest number there is 600 and the smallest is 0. So you will expect our range to be 600 minus 0. And if you look at the graph very well for the y-axis, you would be able to count 6 large boxes. How do you do that? Instead of counting horizontally like we did to the right, from the origin you count upwards and see how many large boxes you can get. And if you do that correctly, you would have 6 large boxes. So for our scale, we have 600 minus 0, which is 600 divided by 6, that gives us 100. What does this imply? It means that for every large box, that one large box on the y-axis would represent 100 meters. And like I said, one large box is 2 centimeters. So we can write it as 2 centimeters to 100 meters, or 2 centimeters to 100 units. Or we can simply put it as a ratio, 2:100. Now don't forget that this scale is only for the y-axis. We already calculated for the x-axis. So the scale can be different for the two axes. It may not always be the same. So note that scales must always be in whole numbers. Now if you do your calculation using the formula that scale is range of values over a number of large boxes, and you happen to get fractions, you are expected to approximate it to the nearest whole number. So going further, we can come to the graph. Remember, we have calculated that our scale for the y-axis is 100, that is 2 centimeters will represent 100 units. That is one large box is 100 units. So starting from the origin going upwards, for the first large box we have 100, second large box 200, third large box 300, fourth large box 400, fifth large box 500, and the sixth large box 600. So this is how you draw your Cartesian plane when you want to plot this kind of graph, straight line graph. Now the next thing will be for us to affix points to look at the positions of each movement. Now come here, look at the table of values again. You will see that from the table of value, 0 minutes corresponds to 0 distance, to 0 meters of distance. 1 minute corresponds to 120 meters. 2 minutes corresponds to 240 meters, and so on. So your job will be to go to the graph, trace 1 on the x-axis, and also trace 120 on the y-axis, and look at where they will meet. Just like we did in the previous class, where we looked at coordinates of points. So if we do that on this graph, but before then, it's important for me to let you know that every large box on the graph contains 10 smaller boxes. If you look at the graph very well, every large box contains 10 small boxes. Now, in that case, if we say 10 small boxes are found in one large box, it will be necessary for us to calculate what one small box will stand for each of the axes, the x and the y axis. Now for the x-axis, remember we said that one large box stands for 1 minute. So one small box will be 1 minute divided by 10, which is 1/10 minutes. And for the y-axis, remember we said that one large box represents 100 meters. So if one large box contains 10 small boxes, so one small box on the y-axis will represent 100 divided by 10 meters, which of course that will give us 10 meters. So for the x-axis, one large box represents 1 minute, then one small box represents 1/10 minutes, while for the y-axis, one large box represents 100 meters and one small box represents 10 meters. So having this in mind, you can go on to plot our graph, but like I said, you need to look at your table of values. This is where you have the information on what to plot. So you can go forward looking at the graph. Remember, the first point is that for 1 minute, Chukwudi walked a distance of 120 meters. So minute is on the x-axis. Trace 1 on the x-axis and trace 120 on the y-axis. Tracing 120 will be after the first large box, then 2 smaller boxes on the y-axis. That will be 120 minutes. So you trace that and you trace from the 1, you will have them meeting up at this point where we have this star mark. The next point is the point where Chukwudi has walked for 2 minutes rather, and you are having him covering a distance of 240 meters. So what do? You locate 2 on the x-axis and locate 220 on the y-axis. You draw broken lines to see where they will meet. If you do that correctly, it will meet up at this new point. The next point is 3 minutes and 360 meters. If you do that correctly, you trace the line, you will have it at this third point. And for 4 minutes and 480 meters, you will have it at this fourth point. And for the last one, 5 minutes, 600 meters, you have it at this fifth point. So this is how you make the points using the coordinates from the table of values. Now, if you look at these points carefully, these 5 points, what do you observe? Yes, I believe you observe that the 5 points are on a line. So we can simply use our ruler, that is your meter rule, and our pencil on the graph sheet to connect these points by a straight line which will go down to the origin. So this is what we call a straight line graph or a linear graph. As you can see, the points are in a straight line and you can connect them using a straight line. So that is how you draw a straight line graph. Now we can use our graph, the straight line, to solve more questions. Let's say we want to use the graph to find how far Chukwudi walks after 2.6 minutes. Now the very simple way to solve a question like this using your graph is to use a method called extrapolation. So you're expected to extrapolate. Now what does extrapolation mean? Extrapolation simply means you looking at the value you are given, drawing a broken line from the value you are given. Now the question says how far Chukwudi walks after 2.6 minutes, which means we have been given the minutes, and where that is the time. Where do we have time? On the x-axis. So what do? Come to the x-axis and locate 2.6. Now 2.6 will be in between 2 and 3. Now remember I told you that on the x-axis, one large box represents 1 unit, but one small box will represent 1/10 minutes. So if we are saying 2.6 minutes, it means that from the thick line where you have 2 minutes, you count 6 small boxes. 6 small boxes. That will give you 2.6 minutes. When you do that, what do? Use your meter rule and a pencil to draw broken lines up to our straight line. Okay, so you draw broken lines from there up to meet our straight line. Now when you look at it very well, there is a point where our broken line intersects the straight line. What do you do next? Take your meter rule again, put it at that point where the broken line intersects with the straight line, and draw another broken line to meet the y-axis in this way. Now when you look at it, look at where the new broken line meets the y-axis and calculate it, and calculate what you have. So this is what we mean by extrapolation, using units from one axis, either the x or the y axis, to find the corresponding value on the other one by connecting them using broken lines to the straight line. So if you look at where this new broken line intercepts with the y-axis properly, knowing fully well that one small box will represent 10 meters, when you do your calculation properly, you will see that Chukwudi has walked about a distance of 310 meters after 2.6 minutes. So this is how you use your graph to solve other problems. Now we can do it on the other way around. Let's say, how long will it take Chukwudi to walk a distance of 500 meters? What method should you use to solve this question? You use extrapolation. But in this case, you have been given the distance, and on our graph, the distance is on the y-axis. So you are going to draw your first broken line from the y-axis. So you come back to your graph, locate 500 meters, draw broken lines from 500 meters to meet the straight line graph. And from where it cuts the straight line graph, draw another vertical broken lines down to meet the x-axis, and then calculate where that would be using the number of smaller boxes and the large boxes. If you do that correctly, you would have 4.2, and that tells you that Chukwudi takes about 4.2 minutes to walk a distance of 500 meters. My dear child, I believe what you have just listened to, the video you have watched, was explanatory, and you will be able to do a similar job. So take your time to go over the video again. You may not have understood it at the first time, but when you watch it over and over again, you will surely understand. So remember that Rome was not built in a day, and a journey of 5,000 miles takes a step to start. So take your first step by watching the video again, and this time around, watch it with your graph sheet by your side, a pencil and a ruler. Every construction made in the video, try to replicate it on your graph sheet so that you have a better understanding of what we are talking about. So my friend, it is time for me to go. Okay, so take your time, watch the video again, watch it correctly, watch it correctly, watch it correctly, and I will see you the next time. But until then, it's a bye from me.